Well, all right, we're moving along here through chapter section 10-3, geometric sequences and series. And we're now come to the point where we're being asked to find the sum of a geometric series. And of course, the geometric series is the geometric sequence, numbers in a geometric sequence added together. And this is following pretty closely, at least in terms of the pattern of what we saw in 10-2 arithmetic sequences and series, although the computations are a slight bit different. Now, we've been given two potential formulas that we can use to find the sum of a geometric series. This is one of those where we've got Sn, that's the sum of the geometric series, is equal to A1, the first number in the series, less A1 times R, the common ratio, raised to the power of n, over 1 minus R. And this will allow us to find the sum of a geometric sequence. And we've been given a little bit of data here where n is equal to 10, A1 is equal to 2, and R is equal to 3. And so we're just going to do a little plugging and chugging here. But I do want to point out, though, before we begin, and I'm not going to do this in this case, but this expression here in the numerator, where we've got A1 minus A1R raised to the nth power, I could actually re-express that like this. A1 parentheses 1 minus R raised to the nth power. And express it like that. And there actually could be a time or two that I may actually want to do that because it would make things life a little easier for me. But this one I'll just go ahead and just plug and chug it. So here we go. I've got Sn is equal to A1 is 2 less 2 times 3 raised to the 10th power over 1 minus 3. Okay, so let's see. Got Sn equals. And so we'll still stick with the 2. All right, now we're going to get some big numbers in these few exercises we're going to do. And let's say I'm going to get 3 caret 10. 3 to the 10th power is 59,049. So here we got 2 times 59,049 over negative 2. And let's continue mathematically. So we got 2 minus, let's see, what's 2 times 59,049? Times 2. Well, that's 118,098 over negative 2. And let's see, that's going to equal negative 118,096 over negative 2. And let's see, negative 118,096 divided by negative 2 is going to give me Sn, running out of room, I'll put it right over here, Sn equals 59,048. Okay, there we go. We found the sum of this geometric sequence when A1 is 2, R is 3, N is 10. Fascinating. Okay, so we're still looking to find the sum of, or partial sum, I really should say, of a geometric series. Sometimes I use sequence when I should use series. I caught myself doing that in the last slide a few times. And this time we're going to use the second partial sum formula that we have. And you might ask, why am I going to use the second one? Well, because I need to. Because if we look at that, we've got Sn, and Sn is equal to, in the second formula, A1, first number in the sequence, less An times the common ratio R over 1 minus R. If you remember, the last one was A1 less A1 times R raised to the power of N. Well, this one was just A1, since we know An and A1. We just got A1 less An times the common ratio over 1 minus the common ratio. So again, we just get to plug and chug, substitution. So we got Sn equals, A1 is 2,000 minus 125, which is An, 125, times the common ratio, which is 1/2, over 1 minus the common ratio, which is 1/2. Let's see, and that's going to equal, I think I can come this way. I got 2,000 minus, let's see, 125 times 1/2. 125, which is the same as 125 divided by 2. And that is, convert that to a decimal, 62.5. So 2,000 less 62.5 over 1/2. And Sn then is equal to, let's see, what's 2,000 less 62.5? That's 1,937.5. What did I say? 937? Yeah, 937.5 over 1/2. So let's see, if I'm going to divide by 1/2, that's going to be the same as multiplying by 2. And so that's going to equal 1937.5 times 2, so that Sn is going to equal 1937.5 times 2, 3,875. Shazam! Find the sum, find the partial sum of a geometric series. Now we're going to look at an example here in a moment using sigma notation. You may recall, well, I'll just get into all that in the next video.